What's going on? Got another video here for you. This is derivatives, and it's the product and quotient rule for a business calculus class. If you're not in business calculus, you might want to watch it anyway, because we do some pretty good, we could do quite a few application problems, word problems that could arise in other classes. So check it out. All right, let's get started. So we've got product and quotient rules. So if we have two functions multiplied together, then the product rule is the derivative of the first function times the second function plus the derivative of the second function times the first function. This is your product rule. And then the quotient rule, if you have two functions divided, is the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, and all that's over the denominator squared. This is your quotient rule. All right, so it's pretty easy. You've just got to know those in order to do it. All right, so let's look at this. So this first problem, I'm going to work it two different ways just to show you something. So let's just look at it. So we've got the product rule. This right here, this would be like our first function, and this would be our second function. So what does the product rule say? It says the derivative of the first function, so the derivative of x minus 1 is 1, times the second function, 3x minus 2, plus the derivative of the second function. Well, what's the derivative of the second function? That's 3. The derivative of 3x minus 2 is 3 times the first function. And then we just need to clear the parentheses, so that's 3x minus 2 plus 3x minus 3, which is 6x minus 5. And that would be your derivative. So you can see it's not difficult to do. You just gotta find the you just gotta follow those properties. Now, I mean, now some of them can get kind of nasty and complicated, but and we'll work some more that are a little more difficult. And basically how this video is done is it's not just, okay, here's a bunch of problems, find their derivatives. It's going to be, okay, you know, we did this example. We'll do some more complicated ones, but it's through word problems. So like it'll be like a word problem, but it's different functions to take the derivative of. Now, let's look at this. Let's look at another way to find this derivative. So let's just kind of move this one. Let's just move this one out of the way down here. All right. So one thing we could do, yeah, we did the product rule. So let's take the derivative of this, but not using the product rule. So what we could do is we could rewrite this as f of x equals, now if I FOIL this out, x times 3x is 3x squared, and then we've got outside, which is minus 2x, multiply the inside, minus 3x, so minus 2x plus minus 3x is minus 5x, and then negative 1 times negative 2 is positive 2. So you can multiply it out, you can FOIL that out, and then take the derivative, and you can see the derivative of this would be 6x, derivative of 3x squared is 6x, minus, and then the derivative of 5x is 5. And you can see you get the same answer either way. So, you know, you might be thinking, well, this way right here is easier. Why do I need to do the product rule? Well, you'll come across some problems where you have no choice but to use the product rule, that you'll see later on in the class when we start doing derivative of natural log and exponential functions, that kind of stuff. And you'll have two functions multiplied together, and you will have to use the product rule. So I would recommend on something like this, go ahead, practice it, do the product rule so you'll get practice at it and you'll know how to do the product rule. Now there might be one problem in here, that when we take the derivative, they're going to want us to use the product rule, and I may use the product rule, I may not. I think it'll be easier not to use the product rule. So, but we'll see when we get to the problem and talk about it. All right, so here we've got another one. We want to find the derivative. You can see this is a quotient. This would be the quotient rule. And so the derivative here would be, the quotient rule is the derivative of the numerator. So the derivative of 2x minus 3 is 2, times the denominator, which is 5x plus 4, minus the derivative of the denominator, which is 5, times the numerator, 2x minus 3. And this is all over the denominator squared. And then we clear parentheses, combine like terms. And so this is going to be 10x plus 8 minus 10x plus 15 over 5x plus 4 squared, which the 10x's, they cancel out. That's going to be 23 over 5x plus 4 squared. And there's your answer. All right, so let's keep going. Here it says find an equation for the tangent line to the curve y equals 2x plus 1 times x squared minus x plus 3 at the point where x equals 0. All right, so we've done some of these problems in earlier videos where we find the equation of a tangent line. So remember, to find the equation of a line, we need the slope and we need a point on the line. All right, so let's first write our point on the line. Okay, so if we write our point on the line, remember it says at the point where x is 0, see where x is 0, they don't give us a y coordinate. So we can actually find the y coordinate by plugging 0 in to our original function here. So 2 times 0 plus 1 times 0 squared minus 0 plus 3, which that's going to be 1 times 3, which is 3. So that's at the point 0, 3. All right. So now let's find the derivative. So y equals 2x plus 1 times x squared minus x plus 3. All right, so let's find the derivative. So we've got y equals, so we've got the product rule here. So that's the derivative of the first function times the second function. Okay, so that's derivative of the first, which is 2, times the second, plus the derivative of the second function, which is 2x minus 1, times the first function, 2x plus 1. All right, and so, and that's y prime. So y prime is equal to 2x squared minus 2x plus 6 plus, and then this is, we FOIL this, so that's 4x squared. And then we've got 2x minus 2x is 0, and then negative 1 times 1 is minus 1. And so we get y prime is equal to, let's see, that's going to be 6x squared minus 2x plus 5. All right. Now we need the slope. So the slope is the derivative evaluated at the x coordinate. It's evaluated at this x coordinate here. And so y of 0 is equal to 6x, 6 times 0 squared minus 2 times 0 plus 5, which equals 5. So this is our slope. And now, all right, so notice we've got a slope of 5 and it's through the point 0, 3. So we can use y minus y1 equals m times x minus x1. And so we get y minus 3 equals 5 times x minus 0. So that's y minus 3 equals 5x. So y equals 5x plus 3 when we solve for y. Okay. All right, so, not bad. Everything in this problem here you should have known. The only thing that's new is doing the product rule. That's what we're learning new. All right, so let's look at the next section. It says a manufacturer determines that T months after a new product is introduced to the market, X of T is equal to T squared plus 3T 100 units can be produced and then sold at a price of P of T is equal to negative 2T to the 3 halves plus $30 per unit. Express the revenue R of T for this product as a function of time, and then B, at what rate is revenue changing with respect to time after 4 minutes? Is revenue increasing or decreasing at this time? All right, so let's write our revenue function down first. So we've got part A, that's R of T. All right, so remember, revenue is the number of units sold times the price, or the price times number of units sold. So we've got a price of this. That's negative 2T to the 3 halves plus 30 times the number of units sold, which is T squared plus 3T. All right, so there's R of T. And now for part B, they want to know at what rate is revenue changing with respect to time, and that's after 4 minutes. So that means we need the derivative. Okay. All right, so this is the one where I thought about, not doing the product rule. So I'll leave that up to you, or if you're not in if you're in my class, I'll leave it up to you for a problem like this when we have a fraction in the exponent. But if you're not in my class, do what your teacher tells you to do. But a lot of times what I like to do is if I have a fraction in the exponent, I like to FOIL it out first. It's just, is it that big of a deal? Sometimes it can be. Sometimes it makes it easier to do the derivative and simplify everything, and other times it may not make that much of a difference. But I guess on this one, let's just go ahead and do the product rule. This is the one where I telling you about earlier, where I thought about multiplying out and then doing it, but let's just do the product rule. All right, so it's the derivative of the first function. So 3 halves times negative 2 is negative 3, because you got negative 2 times 3 halves, the 2's will cancel. Okay. All right, and that's going to be T to the, so the 3 halves comes down, subtract 1 from 3 halves, which is 1 half, and then the derivative of 30 is 0. So this is the derivative of your first function, and then times the second function, T squared plus 3T, plus the derivative of the second function, so that's going to be 2T plus 3 times the first function, negative 2T to the 3 halves plus 30. And they're not asking us in this problem to find the derivative. So the main thing of this problem, it's not find the derivative of this function. They're wanting to know at what rate is revenue changing with respect to time after 4 minutes. So basically the reason we're finding the derivatives is so we can plug the 4 in and find that rate of change. So I'm not even going to worry about simplifying this. So I've got R prime of 4 is equal to negative 3 times 4 to the 1 half times 4 squared plus 3 times 4 plus 2 times 4 plus 3 times negative 2 times 4 to the 3 halves plus 30. And then, hey, punch it in your calculator and you get an answer of, let's see, that's going to be negative 14. Okay, So that's the rate that it's changing. Okay. Now, let's see, what is T? What does T say? What does it say? A manufacturer determines that T months, well, that's not T down there, but it says a manufacturer determines that T months after a new product is introduced, the market X of T, 100 units can be produced and then sold at a price of that dollars per unit. So, all right, so the revenue is changing at negative $1,400 a month, per month, and they want to know, is it increasing or decreasing? Well, since it's negative, then that means it's decreasing. All right. So, you know, we're doing some word problems, but we are getting practice of finding derivatives using product and quotient rule also. All right, so let's look at this one. Now this is one that I didn't write it down in the problem, but they want us to find this derivative in two different ways, and we're going to do that. This one, if I had a problem like this, I would not use the quotient rule on this one. Okay, I wouldn't use the quotient rule on this one. And so let me show you what I would, well, let's do the quotient rule first. So we've got Q prime of X is equal to, all right, so the quotient rule says the derivative of the numerator, which is 2x minus 5, times the denominator, minus the derivative of the denominator, times the numerator. And this is all over the denominator squared. Okay, derivative of the numerator, derivative of x squared minus 5x plus 7 is 2x minus 5 times the denominator, minus the derivative of the denominator, derivative of 2x is 2 times the numerator. And then we need to clear parentheses, combine like terms. So that's going to be 4x squared minus 10x minus 2x squared plus 10x minus 14. And this is all over 4x squared. And so this is going to be, let's see, 2x squared, the minus 10x and plus 10x cancel, and then that would be minus 14 over 4x squared. And then look, 2 goes into each of these. And so that's going to be x squared minus 7 over 2x squared. And that would be your derivative. All right, and you know, as far as doing the quotient rule on this one, it wasn't that bad. But let me show you how I would probably work this. Let's just copy the problem down again. So I think the easier way to do this is to write this as x squared over 2x minus 5x over 2x plus 7 over 2x. All right, and so that would give me Q of x is equal to, that's going to be 1/2 x, right? 1/2 x minus 5 halves plus 7 halves x to the negative 1. See, this is x to the first, so I'm just bringing it up into the numerator. Okay, and then it's just power rule. So that's Q of x, Q prime of x is equal to derivative of 1/2 x is 1/2, and then derivative of 5 halves is 0. Then bring the negative 1 down, so that's minus 7 halves x to the negative 2. Subtract 1 from the exponent, and so Q prime of x would be 1/2 minus 7 over 2x squared. Remember, that's over 1, so if I take it and move it down to the denominator, it changes the sign of the exponent, and there's your answer there. Now, which one's easier? I'll leave that up to you. Sometimes, you know, something like this can get kind of nasty with the using the quotient rule, but But typically what a lot of times what you want to do is if you're taking the derivative and you have this polynomial up here and then you just have a single term in the denominator, a lot of times if you split it up like this, it makes it easier. And you might be thinking, well, this is not the same answer as this, but it is, because we can write this as x squared over 2x squared minus 7 over 2x squared if we split the fraction up, and then you see the x squareds cancel. That's 1/2 minus 7 over 2x squared. All right, and you can see it's the same thing. All right, let's move right along. So it says a biologist models the effect of introducing a toxin to a bacterial colony by the function, this function here, where P is the population of the colony in millions T hours after the toxin is introduced. At what rate is the population changing when the toxin is introduced? Is the population increasing or decreasing at this time? And at what time does the population begin to decrease? By how much does the population increase before it begins to decline? All right, so let's look at part A. So let's write our function down. We've got P of t is equal to t plus 1 over t squared plus t plus 4. And they want to know at what rate is the population changing when the toxin is introduced. All right, so we need to find the derivative, and they want to know when it's introduced. So that would mean we need to evaluate the derivative at t equals 0. So let's find the derivative first. So that's p prime of t is equal to, this is quotient rule, so it's the derivative of the numerator, which is 1, times the denominator, minus the derivative of the denominator, which is 2t plus 1, times the numerator, all over the denominator squared. All right, and so let's simplify this. So we get p prime of t is equal to t squared plus t plus 4 minus, and that's going to be 2t squared. I'm going to FOIL this out, so that's 2t plus t is 3t. 1 times 1 is 1, and this is all over the denominator squared. Now here's something very important here. You see how we fold this out? It's minus this whole thing. You've got to make sure that whole thing is in parentheses, because you got to distribute that negative. So we get p prime of t is equal to t squared plus t plus 4 minus 2t squared minus 3t minus 1 all over t squared plus t plus 4 squared. And so let's see, we get p prime of t is equal to, that's going to be negative t squared minus 2t plus 3 over t squared plus t plus 4 squared. And so let's go ahead and write this. P prime of t is equal to negative. Let's factor a negative. We'll go ahead and factor a negative out. Do you need to do that? Well, you can, but you don't have to. But let's just go ahead and do it. So that's negative, and that's going to be t squared plus 2t minus 3 over t squared plus t plus 4 squared. Now they want to know, we got to go all the way back up here. Let's see, at what rate is the population changing when the toxin is introduced? And so what we're doing here is we're actually evaluating the first derivative at 0. So that's going to be negative 0 squared plus 2 times 0 minus 3 over 0 squared plus 0 plus 4 squared. And when we plug that in, we get 3 over 16. Okay, 3 over 16. So initially the population is changing at the rate of 3/16. And that's going to be, let's see, 316 million bacteria per hour. 316 million bacteria per hour. Okay. And is it, that's what it's changing. And then they want to know, is it increasing or decreasing? Well, we know it's increasing because this is positive. Okay. All right. Now, what does part B say? It says, at what time does the population begin to decrease, and by how much does the population decrease before it begins to decline? Okay, so let's look at this. Okay, let's look at this for a second. So here we're going to do part B. Well, let's see, let's move it up just a little bit in case we need more room. So part B. So we've got P prime of t is equal to negative, and that's going to be t squared plus 2t minus 3 over t squared plus t plus 4 squared. Okay, so we know increasing and decreasing. Okay, it, you know, see what it says here, what time begin to decrease, and by how much does the population increase before it begins to decline. So remember, that has to do with positive and negative with the derivative. If it's positive, that means it's increasing. If it's negative, that means it's decreasing. Well, if we look at this, P prime of t is equal to negative, and that's going to be t plus 3 times t minus 1 over t squared plus t plus 4 squared. Okay, so let's look at this. Just take into account this term here in this denominator, this right here. So when we're talking about t, okay, that represents the time. So we know the time is going to be from 0 on up to infinity. Okay, it can be from 0 to infinity, your time. So look at this. Any number we plug in for t, 0 to infinity, any number from 0 to infinity, do you agree that this term is always positive and this term is always positive? We know it is because, for one thing, that's squared. Okay, but let's look at this. This term, if I plug in a number from 0 to 1, but not including 1, okay? Not including 1. So if I plug in a number, between 0 and 1, okay? Not including 1. Would you agree that P prime of t would be greater than 0? Okay, so look at this. So let's say I put in a half, 1/2, 1/3, 1/5, 1/4, 3/4, 15 over 16. If I plug that into here, that's negative, right? because it's going to be like a half, a third, a fourth, whatever, minus 1. That's going to give me a negative here. A negative times a positive is negative, and a negative divided by a positive is negative. And then the negative I get from this and this negative make a positive. So P prime of 0 would be, or P prime of a number between 0 and 1, not including 1, would be positive. Okay? And so that means P of t is increasing. And then if I do t greater than 1, so that means I'm plugging in like a 2, a 3, or 4. That's going to be positive, positive, positive. So that whole fraction's positive. But then I got the negative in front. So that tells me P prime of t would be less than 0, which means P of t is decreasing. Okay. All right. So what do we learn here? So the population starts to decline after 1 hour. Decline after 1 hour. See, from 0 to 1, it's increasing, but then once it hits 1, then it starts decreasing. All right. And then it asked us, now let me go back up here and see what else it asks. By how much does the population increase before it begins to decline? So how much does it increase before it begins to decline? All right, so let me erase this. I might need some more room. Well, we know that P of 0 is equal to, that's the initial, that's 3/16. And then we need to figure out what P of 1 is. Okay, so P of 1, if we plug in, I'm sorry. P of 0, that's plugging into here. So let's write P of t down. So P of t is equal to, let's see, I got that problem written down. So that's t plus 1 over t squared plus t plus 4. So P of 0, if I plug 0 into here, that's going to give me 1/4. And then P of 1, well, if I plug 1 into here, that's 1 plus 1 is 2. And then 1 plus 1 is 2 plus 4 is 6, which is 1/3. Okay. So how much does it increase before it starts to decline? Well, that's going to be P of 1 minus P of 0, which is 1/3 minus 1/4, which is equal to 1/12. So that's how much it decreases. I mean, that's how much it increases before it starts decreasing again. And 1/12, let's see, 1 divided by 12 is that times, so if we take the 1/12, do 1 divided by 12 and then multiply that times 1,000,000, and so that's going to be 83,333 bacteria. So why did we multiply that times 1,000,000? Because where did it say that? In millions, population in millions. So whatever we get here, see, if you do 1 divided by 12, if you do 1 divided by 12 in your calculator, that's 0.083333333. And then all I did is I multiplied this times 1,000,000, and that's where that number came from. All right. All right, so let's look at this example. Okay, so they want us to find the derivative. Now, this is a problem where, I mean, this thing right here, look, you would have quotient rule here, quotient rule here, and quotient rule here. This is just a constant, so we know the derivative of that is 0. That's no big deal. But we would have 3 quotient rules here. This is one where, okay, we know the quotient rule, but just because we know the quotient rule doesn't mean we have to use it. We can, but why would you if you don't really have to? So what I would do here is I would rewrite the problem as 2/3 x to the negative 2 minus, write that as 1/3 x, that's all it is, plus 4/5 plus, and then split this up, x over x plus 1 over x. So I've got y equals 2/3 x to the negative 2 minus 1/3 x plus 4/5 plus 1 plus x to the negative 1. I wrote everything out where I can just use the power rule. And this is not hard going from here to here. That's not that difficult. You would have a lot more work you would have to do if you did the quotient rule on this, this, and this. So I just rewrote everything, and now my derivative, that's going to be negative 4/3 x to the negative 3, the negative 2 comes down, subtract 1, minus 1/3, derivative 1/3 x is 1/3, derivative 4/5 is 0, derivative of 1 is 0, derivative of this, the minus 1 comes down, and subtract 1 from the exponent. And so that's going to give us y prime is negative 4 over 3x cubed minus 1/3 minus 1 over x squared. And there's your answer. All right. So it's not too bad. Just use your head when you're doing this. Say, would it be easier if I didn't use the quotient rule? Now, don't get me wrong. There's sometimes you're going to have to use the quotient rule. All right. So now let's take a look at some problems dealing with second derivative. So the second derivative of a function is the derivative of its derivative. And if we have y equals f of x, the second derivative we can denote like this. These are just different notations for the second derivative. All right. So here they want us to find the second derivative. So we've got f prime of x is equal to, well, take the derivative. 4 times 5 is 20. Subtract 1 from the exponent. 2 times 3 is 6. Subtract 1 from the exponent. Derivative of minus 3x is 3. Derivative of 7 is 0. And then the second derivative, I just take the derivative of that. So that's going to be 60x squared minus 6. And there's your second derivative. This one, on this problem, the book actually uses the product rule. But this one, I wouldn't use the product rule on this one. I would distribute. Okay? And when you distribute, you get y equals 3x cubed plus x squared. And then you find the second derivative. So y prime, that's going to be 9x squared plus 2x. And then take the derivative of that. That's going to be 18x plus 2. That's how I would work that one. But since we're learning product rule and quotient rule, let's work this one out using the product rule so we can see it. Okay, it's good practice. It's good for you to see this. So the product rule, but don't get me wrong, this is how I would work that problem. All right, so for this, I do the derivative of the first times the second plus the derivative of the second times the first. Okay. And then let's clear the parentheses, combine like terms. So y prime is going to be 6x squared. Let's see, 6x squared plus 2x plus 3x squared. And so y prime is 9x squared plus 2x. So that's the first derivative. Now, and you can see that's what we got here. And then the second derivative is going to be 18x plus 2. So you get the same thing either way. Which method do you use? Well, if your teacher tells you to use the product rule, you got to do it this way. If they don't say anything, just distribute that and then do it. Okay? All right, so let's see what we've got here. It says an efficiency study of the morning shift at a certain factory indicates that an average worker who arrives on the job at 8 a.m. will have produced this many units T hours later. This is the number of units. Compute the worker's rate of production at 11 a.m. and at what rate is the worker's rate of production changing with respect to time at 11 a.m. All right, so to compute the worker's rate of production, if this is the production, then the rate of the production, that would be the first derivative of this. And then at what rate is the worker's rate of production changing? So at what rate is the rate changing? That would be the second derivative. Okay. So for this problem, basically all we've got to do is take the first derivative, plug in 3, so see what we get as an answer, then take the second derivative, plug in 3, and see that would be our answer. So why are we plugging in 3? Well, it says they arrive at 8 and they want to know at 11. So 8, 9, 10, 11, that's 3 hours later. So all this means is t equals 3. It would be the same. It's the same thing as saying compute the worker's rate of production at t equal 3. Okay, they're just making you figure out what t is. So part A, we've got q of t is equal to negative t cubed plus 6t squared plus 24t. And so this right here, this would be we could call it r of t, which is the rate, which is the first derivative. I mean, if you want to put r of t, you can. You can probably use whatever letter you want, but it's just the first derivative of this function. So that's negative 3t squared plus 12t plus 24. And so now we have q prime of 3, which is r of 3, same thing. We just plug the 3 in. Negative 3 times 3 squared plus 12 times 3 plus 24. And that's going to be 33 units per hour. That's the rate of his production. That's the worker's rate of production 3 hours later. 33 units per hour. And then for part B, well, that's the derivative of r of t, which is actually just the second derivative of q of t. So this is going to be negative 6t plus 12, right? We're taking the derivative of this thing. And so we've got r prime of 3, which is q double prime of 3. I'm just writing this q double prime and q prime here to show you that this is the first derivative, this is the second derivative. And so that would be negative 6 times 3 plus 2, which that is, oh, wait a minute. Oh, I'm sorry. That's not 2. That's 12. That's plus 12t. So that's going to be negative 6. So what does that mean? So that means his rate is decreasing at 6 units per hour at 11 a.m. Okay, because of the minus sign, that means it's decreasing. Okay, all right, and then here I think Okay, so we don't have a lot more, so keep watching if you're watching. If the position of an object moving along a straight line is given by this at time t, find its velocity and acceleration. So this is s of t is equal to t cubed minus 3t squared plus 4t. All right, so the velocity, v of t, that's the derivative of the position function, right? That's your velocity. Okay. Remember, we have a position. The change of your position is velocity, and so that's going to be 3t squared minus 6t plus 4. And then the acceleration is the derivative of the velocity. So acceleration is the derivative of the velocity, which is also, or the second derivative of the position function. So that's 6t minus 6. All right, that's all they wanted you to do there. That was pretty easy. All right, so what about this one? Find the fifth derivative. So that just means we just keep taking the derivative until we get to the fifth one. And so that's going to be f prime of x is equal to 12x squared plus 10x minus 6. That's your first derivative. Well, let's take the second derivative. So the 2 comes down, that's 24x plus 10. And then the third derivative, well, derivative of that is 24. And then the fourth derivative, so, you know, for the first derivative, it's 1 mark. For the second derivative, it's 2. The third derivative, it's 3. And you might be thinking, well, for the fourth derivative, it's 4 marks. No, when you get past the third derivative, you put the fourth derivative, you put it in like parentheses up there. And so that's 0. And then, of course, the fifth derivative, well, the derivative of 0 is just 0. Okay, so there's your fifth. You just keep taking the derivative of the previous derivative. Now this one, this is 1 over x. I would not do the quotient rule here. First thing I would do is rewrite this as y equals x to the negative 1, and then use the power rule. So I've got y prime is negative x to the negative 2, right? The negative 1 comes down, subtract 1. The second derivative, negative 2 times negative 1 is 2, subtract 1 from the exponent. The third derivative, the negative 3 comes down, negative 6, subtract 1 from the exponent. And then the fourth derivative would be 24x, subtract 1, that's negative 5. And then the fifth derivative, that would be, well, let's see, what is 24 times 5? That's 120. So negative 120x to the negative 6. And so the fifth derivative would be negative 120 over x to the 6th. And so this one you would write with the positive exponent. I don't care about these up here because those aren't the answers I'm looking for. So I don't care about rewriting them with positive exponents. It's just I'm going to write my final answer with a positive exponent. All right, so that's this video. That's it. So I hope this helped. Hope you understand it now. But check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.